Hi, and welcome to our discussion of thunderstorms. In this discussion, we're going to talk about the hazards, but more specifically, we are going to look at wind shear. And this continues our discussion on wind shear. We already went through weather producers and also talked about inadvertent encounters. In this video, we're going to go over the model of flight crew actions. So back in the 1980s, there were quite a few aircraft accidents as a result of wind shear. Lots of airlines were having problems with aircraft flying into and out of airports where there were thunderstorms and wind shear. So with those accidents, the FAA spent large sums of money to protect airports from wind shear and aircraft from wind shear, as much as providing specialized Doppler radars around airports, which we call TDWR. They also put quite a bit of effort into training. One of the things that came out was an advisory circular, which is called AC00-54, which is the Pilot Wind Shear Guide. And the Pilot Wind Shear Guide was developed by a couple of think tanks. And one of the things they did was they came up with a model of flight crew actions. And what this is, basically, it's what the pilots should do when they fly into and out of an airport to evaluate the risks associated with wind shear. So here's the flow chart. Starts at the top and goes down to the bottom. Of course, the very first thing at the top is evaluate the weather. So of course, when you're flying to an airport and you are concerned about wind shear, you want to look at the weather, of course, and take a look and see what's happening around the airport. And that means looking at all available information, which includes observations and forecasts, whether it be TAFs, METARs, weather watch boxes, whether it be a tornado watch or severe thunderstorm watch, the low-level wind shear alert system around the airport also, if there are any warnings or any alerts going out from that, that would be really informative, as well as convective signals for the area. But there are other things also, such as visual clues as you fly into or out of an airport. Are there cumulonimbus around the airport, towering cumulus? Pilot reports are invaluable, especially aircraft on final approach or taking off. And then finally, of course, being able to use your radar, the airborne weather radar, or for that matter, the ground-based weather radar, whether it be TDWR or the WSR-88D network through data link or other sources. So what the FAA did, or at least their contractor, they tried to assess the clues that would tell you something about wind shear, if there's a possibility of wind shear. And they assigned probabilities to these clues. So this is if you have convective weather near your flight path going into or out of an airport. Do you have strong localized winds? Strong localized winds would give you a high probability of wind shear. If there's heavy precipitation at the airport or along your flight path, then there's a high probability of wind shear. Rain showers, lightning, and virga, as well as moderate or greater turbulence, or a temperature dew point spread of 30 to 50 degrees Fahrenheit, all give you medium risks. If the onboard wind shear detection alert system is going off, you have a high probability of wind shear. If on final approach or on departure you lose or gain 15 knots, then that's a high probability. If your indicated airspeed changes by less than 15 knots, it's a medium probability. And then so on and so forth. If the low-level wind shear alert system has a change of more than 20 knots across the anemometers, then there's a high probability, less than 20, medium. And then only if there's a forecast of convective weather, that is low probability. So all of these probabilities kind of give you an idea of whether there is a good chance of wind shear or not. They also go on to say that if you combine these clues, two mediums would equal probably a high, or if you have a high and a high, then you have a very good chance of wind shear. And also these all apply to the airport vicinity, which is 3 miles and 1,000 feet AGL. If the hazards are closer to the airport center, then the probability and the risk level goes up higher. So the first thing you do is evaluate the weather. After that, are there any signs of wind shear? If there are no signs of wind shear, then you just go down to the very bottom and you follow the standard operating techniques. If there are signs of wind shear and you consider it safe to continue, then you have to consider precautions. So in other words, you're coming into an airport, you might have a towering cumulus cloud, and that doesn't tell you that there's wind shear, but if the towering cumulus develops into a cumulonimbus, then you need to be ready to take action. So what are some of the things that can help you avoid wind shear or give you the advantage over wind shear? Well, it depends on whether you're taking off or if you're coming in for an approach. Some of the takeoff precautions are things like using maximum rated takeoff thrust. So in other words, using all the thrust available. With transport type aircraft, sometimes they use reduced thrust takeoff. And then also using the longest runway, using the manufacturer's recommended flap settings for wind shear encounters, using increased rotation airspeed to get more energy once you're in the air. And don't use the reference flight director, the speed reference. Remember, we said in earlier videos that you're really not concerned about flying airspeed, but more so pitch. If you're coming in for a landing, however, the precautions are a little bit different. So some approach precautions are things like a stabilized approach no later than 1,000 feet AGL, minimizing your thrust reductions. The reason for that is typically if you encounter a microburst on final approach, you'll get an increasing headwind first, which means you'll have a bump in airspeed, and typically that means reducing power or reducing thrust. So in this case, they want you to just leave the thrust setting or the throttle where it is. Use the most suitable runway, concerning where the microburst is located, and then also consider using your flap settings as the manufacturer states. Other approach precautions include using a higher approach speed. We talked about that with gusty conditions, so you can do that also with wind shear. And then also use your autopilot to shoot the approach so you can monitor and take action as needed. So those are your precautions. After that, you want to follow standard operating techniques. And standard operating techniques can be broken down into takeoff and approach. So this is very similar to what we call control performance for instrument flying. If you know the numbers, if you know the attitude or the pitch attitude, number of degrees up or down, the climb rate, the power setting, and the airspeed, then you will know your standard conditions for the aircraft. And if anything is unusual, if you have a very high thrust setting and a very low airspeed, and the airplane is not climbing but descending, you know something's wrong. So follow standard operating techniques, and when things are not standard, when things are different, then you know that you are perhaps encountering shear. So that's using all the all-engine initial climb attitude, and then also making continuous rotation. Also, other things are you can use your flight director, but cross-check it. Also, minimize the pitch attitude reductions. We talked about that and how the airplane will descend to the ground if you let it in when it encounters wind shear. But also monitor your vertical speed and call it out. Have good crew coordination so that your pilot non-flying is making the call, so that the pilot flying is aware of the condition of the aircraft and the status of the aircraft's airspeed, vertical speed, and altitude and thrust settings. And also know the recovery decision guidelines. We're going to get to that here after a little bit. As far as approach, here's some standard operating techniques. Once again, very similar to departure. Know your normal attitudes, ascent rates, airspeeds, throttle position, cross-check the flight director, avoid large thrust reductions, monitor VSI, make callouts, and know your recovery decision guidelines. So here are your recovery decision guidelines, and what these are, if you encounter any of this, then that probably means you're encountering severe wind shear. and you need to do something. In other words, you need to recover the aircraft from the wind shear. So these are your limitations. When you hit this, it's time to kick into high gear and perform the recovery for the aircraft. On takeoff, it's if your pitch changes or your pitch changes by more than 5 degrees, plus or minus 5 degrees of pitch attitude, airspeed plus or minus 15 knots, and also your rate of climb plus or minus 500 feet per minute. And then approach, it's if you're above or below the glide path by more than 1 dot, or you have an unusual throttle position for an extended period of time. If any of those occur, then it's time to follow the recovery technique. So what is your wind shear recovery technique? Depends upon if you have just lifted off or if you are on approach, final approach. And also, it depends also if you are on the runway taking off. So let's look at after liftoff and on approach recovery first. So if you've just lifted off from the runway and you're climbing out, or if you are on final approach, then you need to apply all the thrust that you have, pitch the airplane up to 15 degrees pitch attitude, but you might have to pitch it higher to get an acceptable flight path. But do not stall the airplane, and that's what stick shaker is. And then configuration, don't bring the flaps or gear up. They want you to fly the airplane and focus all your attention on flying. So leave the gear down and also the flaps where they are. As far as on the runway, if you're on the runway when you encounter shear, then you need to apply all the necessary thrust, rotate up towards 15 degrees, no later than 2,000 feet with runway remaining, and then increase beyond 15 degrees to get the airplane airborne. And that may require an airspeed less than VR. So here's some pictures to go with that. Of course, if you're on the runway, the airplane doesn't excel very rapidly. So you are probably below your rotation speed. And for that matter, perhaps your decision speed. If you're below your decision speed and there's runway remaining, you can stop on the runway. But if you're still below the decision speed or even rotation speed, and there's not much runway left, then you know you're going off the end of the runway and you need to get the airplane airborne. So it may take quite a bit of effort to get the aircraft off the ground and unstuck below VR. But the airplane will probably become airborne with less than 2,000 feet remaining. And from that point on, adjust your flight path with pitch. So that's the model of flight crew actions for encountering and surviving wind shear. I hope you enjoyed this video.